So hello everyone, in the previous video we talked about different ways to access the data from a data frame. Now in this video we are going to talk about the different kind of operations that can be performed on a data frame object. Now this is going to be a lengthy video. Why? Because there are different kind of operations and the same operation can be done in a different way. It might be modification, it might be arithmetic operations and different, right? So bear with me. So first operation that we are going to see is assigning or modification. That is, given a data frame, how we can modify any particular piece of data in it, right? So as we have seen in the earlier video, so we imported our pandas and then we imported our numpy, and then we created our data frame object using a ND array, numpy array, right, of 4 columns and 5 rows, total of 20 elements, right? So we are going to use the same data frame, not create another, right? So this is our data frame, right? So the first thing is to change a value, right, or modify a value. So suppose I want a particular value to be changed, right, like C3, it is 2, I want to make it 12 maybe, right? So now how it can be done, as we have done in the previous video where we talked about accessing the value. So first we will try and access it and then we'll try and modify it. So how we can access it? df. Now the first value will go for its column name, so its column name is C3, so let's make it C3, and then we'll go for its row value. Now what is its row value? It is R1. So we will see that whether we can obtain the value or not. As usual, we have obtained the value 2, right? Now let us modify it, that is assign a new value to it. Maybe I'll assign 10 to it, doesn't matter, right? Or maybe 12, something of that sort, and then we'll execute it. So it has worked or not, let's check. So when we put df, so as usual was 2 and now it has been modified to 12. Does it make sense? So this is how we can change an individual element. We can also change a column value. So suppose I want to add you see 10 to each and every element, and so this will become 10, this will become 15, this will become 20, and this will become 25. Now we can simulate this behavior also. So we do remember how to access a particular column. So what is the column name? C1, right? Now as we will modify it, so we'll assign a list of values. So how many values should be there? Because there are 4 rows, so 4 values should be there. So 10 comma 15 comma 20 comma 25, right? And let's see whether it works or not. So now we'll try and get it. So as we can see, each and every value of a particular column has been updated, right? Now the similar behavior can also be replicated using rows. So now for changing the value of row, it will behave somewhat like a subset. So we do remember how to access a subset using loc function. So df dot loc. Now it's different for rows and column method. So loc, so the first value is for the row. So which row do we want? We want to change only R1. So we'll put R1 colon R1, right? And we'll just leave it as it is, comma. Now we want to just change this, all of these column values, right? So 10, 11, 12, 3, 4, everything has to change. That means all the columns has to be included. So how we can do that? We can go colon colon, right? So now let us see what it actually prints, and then we can actually see whether we can actually modify it or not. So we'll print it, print R1 is not defined, right? Because it's a string, we have just put R1, so that's why it threw an error. So it's an important thing that we have to understand the errors also. The problem was that these are all in string formats. R1, R2, R3 and R4 are all string labels. So we just put R1, so it took it thought that R1 is some sort of an identifier, so that's why it complained. So as usual, the entire row has been selected. Now we can just use the similar code and assign new values to it. So we'll do that, and then we'll assign a list of values. So how many values have to be assigned? 5, right? 1 2 3 4 5. So let us assign 5 values to it. Again we'll just add 10 to it, so 10 plus 10 is 20. So that means each and every value that was previously there, we'll just simply add 10 to it. Now there are more easier method to do it, but for instance we'll just make it simple, right? Some automated ways to do it. So it's 11 and then 22, then 13, then 14, right? And let's see whether it works or not. Yes, now we'll print our data frame again. Now we can see it has updated. Both row and column values can be updated. Does it make sense? So this is how we can just change or assign new values to it. So this was the example where we just did it. Now different examples are given in here, so you can check it out, how to change an entire column of a data, right? Complete row of a data, how to change complete row of a data. Now the next thing that we are going to see is adding a column in a data frame, right? So in this particular data frame we have 5 columns. Now suppose I want to add another column, so it's doable. So now the idea is that if the column doesn't exist and we are trying to assign values to a column that already doesn't exist, then what pandas will do, it will just create that column. Does it make sense? So that's the idea behind it. So we'll try and create a new column. How? 6, C6 we will create, and here we'll just assign some values to it because it is required. So np dot nan, right? So we are assigning nan to it. Let's see whether it works or not, and we'll print df. So as usual we can see a new column has been created with nan values. Now we could have changed it. If we wanted some new values, we can just add values to it, right? So suppose I want to add a, b, c, and d, right? Because there are 4 rows, so we want 4 individual values, right? So earlier we added nan, so now we will actually add some values. Let's see. So now we can see a, b, c, d has been added as a new column, right? So that is how we can add new column. That means if the column doesn't exist and we want to assign value to a column that doesn't exist, then pandas will create it. Does it make sense? So that's an idea behind adding columns, right? So a bit of explanation is also given. Go through the blog post and it will make more sense. So now deleting columns. So for that we have attribute called as del. We can use it, right? Using this particular command we can delete a particular column, right? And we also have a drop function. Using a drop function we can remove multiple columns from the data frame. Does it make sense? And obviously axis 1 means column and axis 0 means row, so that kind of an idea can be applied. So go through the blog post and it will make more sense. Also have mechanism to delete rows from a data frame, right? So the idea is that similar behavior, which row and which column do we want to delete, right? And then add axis. So axis 1 means column, axis 0 means row. We are aware of it. So this was our actual data frame. So 1, 2, right? So 1, 2, that is first row. So we can see the values starting from first row all the way to the second row has been deleted. So that's why 0, 3 and 4 is there. The similar behavior is obtained in here. 1, 2, that means this and this particular column, because axis 1 means column, has to be deleted. So that's why our final result has only the 0th column, and obviously these are the indexes. We know that only one 0th column is there. Does it make sense? Okay, now we can also iterate over the data frame. That is, given the data frame, we can run iterrow function, right? We can perform the iterrow function and get the data in it. Okay, so we'll just see how it actually works. So we have row index and row series. So now let us do it. So given this data frame, what we can do for, because 2 values are there, so we can just call a comma b in df dot iterrows, right? We will just print a, that will give us the indexes. Then on the next line we'll print b, and let's see what we get, right? So now iterrow will move over each and every row individually, right? So first row will be seen, and then second row, then third row, then fourth row. Now the index value of the first row is r1, so that's why r1 has been written, and its value for c1 is 20, c2 is 11, c3 is 22, and in this way it is being listed. Now we can see it is a series object, right? So this b is a series object, that's why only one dimensional data is obtained. Now it goes through the second row, which is r2, and all the data that is there in a series object format is being written, right? So we have iterrows as well as we have iteritems. So iteritems is basically for the column data set. Now what does it mean? So if I have to iterate over the columns, then we are going to use iteritems. Similar behavior. So what we are going to do for maybe c comma d, just two variables in iteritems. Obviously it belongs to df, so we have to mention df dot iteritems, that is iter over the columns that are present in the df data frame. So again we are going to print the column name, that is c, that is stored in c, and then we'll print the column data stored in d, and let us execute it. So we can see the first column c1, right, has 4 row values 20, 15, 20, 25, and its data type is also listed. Does it make sense? So this was our first column, 20, 50, 20, 25, and 11, 6, 11, 16. So we have where is our second column? Yeah, here is our second column, 11, 6, 11, 6, 16, right? And in this way we can iterate or run a loop over a data frame, and at certain times it's important you see to run a loop over it and iterate over the data set and perform some sort of an operation on it. Does it make sense? Right. Okay, now let's talk about arithmetic operations on data frame object. Right, for that we need to create two data frame, and based on these two data frame we will try and perform different kind of arithmetic operations, like see addition, subtraction, division, multiplication, something of that sort. And we'll also look into applying functions, numpy mathematical functions on these data frame, and let's see how it behaves, right? So for that purpose we'll create two data frame. So here we are in our Jupyter notebook. So we'll start with importing So as there are we are reshaping this particular one-dimensional array into 2 rows and 3 columns. So that means we have to provide 3 column names. And as there are 2 rows, so we will have to provide 2 row name. So we are going to copy this piece of code so that we don't have to type it again, and we'll make some subtle changes in it. Now we'll print the data frames. So it seems we have some sort of an error. Let's cannot reshape. Okay, so I think there is something wrong, so it will be 12 itself. Yeah, now it's working fine. Yeah, so now we have 2 data frame. This is the first one and this is the second data frame. So if you want, we can just remove this print statement so as to give us that row and a column feeling. But if you are writing the similar code in either spider or idle, then it's not going to work. Print statement has to be there, right? So this is the column and the row structure of it. Fine, does it make sense? Fine. So what we actually did, let me reiterate, we have created two data frames that consist of 6 elements. So 0 to 6 is 6 elements, right? And we have reshaped into 2 rows and 3 columns, and we have provided names of the column and names of the rows through index and column argument. Does it make sense? Now we can jump into performing different operations on it, right? So let's try and do addition on this. So I'll try print df1 plus df2, right? So we'll try and do that. So now what we can see, actually the two data frames has been added based on their matching indexes, based on their matching row column numbers. So that means column 1 and row 1 of df1 will be added to column 1 and row 1 of df2, and because of that we have 6 in here, right? So let me just add the print statement again, so as to make it more visible. Again we'll do that same in here, right? And let's hit enter. So 0 plus 6 is 6, and 1 plus 7 is 8, and 2 plus 8 is 10, right? So that is how we can perform addition. Now similarly we can also perform subtraction from it. So print df2 minus df1, right? And that is the value we get, right? So 6 minus 0 is 6, and 9 minus 3 is 6, and that is why we are getting it. So we do understand every operation, every arithmetic operation on a data frame actually gets done on the matching index and the column number, right? So based on the matching cell number, they will get added, subtracted, or any kind of operation. So similarly we can do multiplication and division also. So let us just do it quickly, right? And obviously that is what we get over here. Now this particular thing, it has done both multiplication and division. So these are the result of the multiplication, and these are the result of division. Now from our basic understanding of the operators, arithmetic operators, division always result into a floating point answer, right? And this INF stands for infinity because we were trying to divide df2 by df1. So df2, this particular element is 6 and df1 is 0. So if you divide anything by 0, it will result into an infinity, right? So that is what it's given here, right? So INF stands for infinity and NaN stands for not a number. So does it make sense? So this is how we can perform basic arithmetic operations in it, right? And obviously we can multiply it with the scalar also. Let's try and see that. So if I multiply df1 by 2, let's see what happens. As we can see, each and every element gets multiplied by 2, and it's basically based on the index, not as a entire data frame itself, right? It's some sort of a vectorized operation. Fine. So arithmetic operations, again go to the blog, so you'll find all the examples and as well as a bit of explanation on it with proper coding in it, right? So now we are going to apply some numpy or math functions in it. So suppose first is the square. So our df1, what is the value of df1? So now if I want to square each and every element, we can do it. We can write np dot s square, right? And we'll pass df1 in it. What is the error? Yes, oh yeah, typo, right? And as we can see, each and every element has been squared up, right? So 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, right? And then the similar way we can also perform square root. So if you go to the blog post, you can see different functions that we have applied, like square, sqrt for square root. We have also computed the sign value of all the individual elements of the data frame, right? So this is what we can do. Now the next thing that we can do is comparison in between data frame objects, right? So it's similar to, equal to, less than, greater than, that kind of an idea. Does it make sense? So let's try and equate it and let's see how it behaves. So as we know, we have two data frames, and this is df1, and let us print df2 also. So this is our df1 and this is our df2, right? So let us try and do that. So df1 is equal to df2. So again, we know that this is a comparison operator, right? It always results in true or false. So that's why it is giving false, because not a single element of df1 and df2 are equal, right? So what will happen if I put greater than or maybe less than? Df1 is less than df2, and again it is true because each and every element of df1 is smaller than the respective elements of df2, right? So that is how we can perform different kind of arithmetic, right? And even comparison and logical operators on it, right? Does it make sense? So next we will discuss about functions, and thanks for watching. Do subscribe to the channel for